All right, so from the practice chapter 2 test, problem number 2, problem number 4, okay, and problem number 25, okay. Some things. First of all, always try to factor. I'm actually going to show you this number 2 real quick. I can factor this. Does anybody see anything in common between these two numbers? X, yeah. Anything else? 2, yeah. So I can take out a 2x. And if I divide out a 2x, what's left? So 2 goes into 2 once, right? And if I take one of these x's away from my x squared, then I'm left with just x. Okay? Now how many times does 2 go into 6? 3. And if I take an x out, then how many x's are left? None, right? Okay. So I'm left with 2x times x plus 3 equals 0, right? And then all we want to do here is say, okay, then 2x equals 0 and x plus 3 equals 0. Okay? And so then I divide by 2, and I get x equals 0. And I subtract by 3, and I get x equals negative 3. And so my final answer is negative 3 and 0, because I want to put them in order from least to greatest. Does that make sense? Right? So that's factoring. Okay? And always, and I know sometimes I'll be like, hey, do this using quadratic formula. You know, and if they do that on a test and they leave you a spot where you got to show your work, then yeah, do it using quadratic formula. But if they're giving you A, B, and C as an answer, right? And they're like, use quadratic formula. Use, I don't know, completing the square. F that. Who cares? Because all they want is the answer, right? So use what you think can get you the answer. If that means plugging in their answers to see which ones work, do it. Because it's a test. And a test, you do what you have to do to get it right. All right? Use all your tools. Don't just use the tools that they give you. Okay? Because sometimes it's a lot harder with the tool that they give you. Okay? If they would have told me use quadratic formula for this, I would have been like, why? I don't, and that's exactly what they told my Algebra 2 students. They had the same problem. Use quadratic formula. Why? I can factor that. Why would I use a quadratic formula? Okay? Factor it. It's quicker. Still get the answer. Alright? This one, I want to check it. Is it factorable? The product is 12, right? And the sum is 4. And we're subtracting. So what two numbers multiply to be 12 and subtract to be 4? Are there any? 6 and 2. Okay. So I guess we can use that. And yours came up as a square root of 12, didn't it?
For 4? Mine came up with 2 plus or minus square root of negative 32 over 4. And then I did a background division, and I got 2 pairs of 2s, so I took out 2 2s, and then I subbed it in.
Is this the, did I write the right thing?
Yeah.
Yeah, it's quadratic formula.
Oh, I know what I'm doing wrong. I know what I'm doing wrong. Watch this, guys. Watch this. Sorry. I have to remember something here. 2 negatives make a Positive. Right? And that means two numbers that multiply to be 12, but add, in this case, add to be 4. So are there any numbers that multiply to be 12, but add to be 4? No.
Yeah, this is quadratic formula.
Yeah, I know. And that's what, but I knew you had to use it, because this isn't factorable. We can't factor this. Right? And that's what I'm trying to prove. Is sometimes you have to use the quadratic formula. You just have to. Okay? So, in this case is one of them. Okay? I have to use the quadratic formula. Okay? So, that means negative b. Right? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Whereas you have a, b, and c. Right? So I start to plug that in and I go, okay, I've got negative b. Notice when I say the letter, I write the parentheses. It's so important. Plus or minus the square root of b squared minus 4ac all over 2a. Okay? And now I start plugging in numbers. Okay, what is b?
Negative 4.
Yeah, no.
Yeah, but the negative.
Yeah, but we're going to plug in the positive 4, right?
Yeah.
I see where you're going. But yeah, we got to plug in a positive 4. Okay? And that means a positive 4 goes here too, right? All right. So what's a? Negative 2. And that means we have to put in that negative 2. Okay? And then what's c? Negative 6. Okay? So that means we have to plug in that negative 6. And now we can do the math. Negative 4 is negative 4, right? Plus or minus 16, right? What's a negative times a negative times a negative? Negative. Right? And then 4 times 2? 8 times 6? All over negative 4. Now, you had 32, didn't you?
Yeah.
But isn't it negative 32?
Yeah.
Okay.
That's
a big difference, right?
Yeah.
Okay, so we got negative 4 plus or minus the square root of negative 32 all over negative 4. Okay? And this is where we have to start taking out some stuff. We got that negative 32 and we're going to break it down. What's the first thing we take out from negative 2? When we have a negative and it's in a square root? I. Okay? That leaves us with 32. And then we start with our 2's, and that's 16, 2, 8, 2, 4, 2, 2, 2, 1. Okay. Now we do our circles. This is a pair. This is a pair. By the way, I always comes out. So I kind of like to circle it so I know it comes out. Okay? So, I got negative 4 plus or minus 2 times 2, which is 4i, right? And then what's left in the square root? The last 2. Does that make sense?
Yeah.
All over negative 4. Now, here's the trick. What goes into negative 4? See, when I have a negative in the bottom, I want to get rid of that negative. So I'm going to divide by the negative. But I also want to, what goes into 4, 4, and 4? Well, that's 4, right? How many times is 4 going to negative 4 going to negative 4? Positive once, right? How many times is negative 4 going to 4? Negative once. But remember, that would just flip these signs. So we're just saying it's 1. 1 what? 1i. Square root 2. And then how many times is negative 4 going to negative 4? Once. And that's when you're left with that. What does it mean to have I? It's imaginary. Why? We know that this thing's frowning, right? What it means is that wherever this is, it's frowning underneath. You see what I'm saying? And the shadow is coming up and crossing here. That's the shadow, the imaginary part. Okay? Because it's frowning, I know it's frowning underneath the x-axis. Does that make sense? I don't know where. I would have to do my axis of symmetry work, right? To find out where. How are we doing? Good? All right. Factoring. Whew, this is a good one. Okay? This one's tough. This is a big factoring problem. It's not that bad. What's your first step to factoring? GCF. What's the GCF? What goes into all of this? 5, right? Okay? So that means I've got 7x to the 4th plus, 2 goes into 24 times with 2 left over, and 5 goes into 25 5 times. And then 5 goes into 25 5 times with a 0. Okay. So we're left with that. Does that make sense? So we have 5 times 7x to the 4th plus 45x squared plus 50. Okay? And now we want to factor that last part. So what's the second step? Parentheses star variable, right? So we're going to pull this down. We're also going to pull this down, right? And go 7x squared. Remember, it's always half of that guy. Remember, half. Okay? And this is going to be 7x squared. Right? And that's a star variable. Okay? Alright, and then we got signs. And that means this sign comes down. And this sign tells me they're the same or different, right? So are they what? What are they? Same. So they're both plus. Okay? Now we're dealing with the product and the sum. And we're adding in the sum. And what is the product? The product is 7 times 50. Well, you don't have to put that together to break it back down. Our whole point is to break it down, right? So think about that. Isn't that 2 times 5? Or sorry, 2 times 25? Right? So that would be 7 times 2 times 25. Well, wouldn't that just be 7 times 2 times 5 times 5? Right? And so we broke it down. Now we got to rearrange those numbers so that when we add the numbers, we get 45. Okay? And I see it right away. I don't know about you, but when I think about 7 and 5, I get 35, right? And 2 and 10, I get 10. Or 2 and 5, I get 10. And what is 35 plus 10? Huh? 45, which is what we're looking for, right? So I got 35 and 10. Alright, now what do I got to do? Right? I got a star cleanup, right? So that was my product and my sum. And now I got star cleanup. Okay, that means my star was 7, right? So I need to take out a 7 and a 1. Which one of these does 7 go into? That first one, right? The 5 is still there, so we still have the 5. How many times does 7 go into 7? Once. How many times does 7 go into 35? 5. And 1 goes into 7, and 1 goes into 10. And that's it. That's factoring on the big scale. Does that help?
Yeah, how come for product and sum you did it differently than normal?
Yeah, I usually put it together and then break it down, right? This year I'm changing the way I'm teaching it. Because I found that to be a little bit, what's the word? Redundant. Does that make sense? We put it together just to break it down. It's like when you're wrestling somebody, I'm going to let him stand up just to take him back down. Why? If I let him stand up, what could happen? He could get away, right? How about I just keep him on the ground? You know what I mean? And so that's what I started saying. I was like, why am I putting these together just to take it apart? That's kind of silly, right? So I adjusted the way I teach it because I'm always trying to learn a better way of doing things. So I'm glad that you noticed it. And I'm sorry that it's a little different than I taught you last year. But I'm not too sorry because I think it's better. Does that make sense? Yeah. Good question. Did we make it?